Section 2.2, right triangle applications. All right, so in math, whenever you hear the word application, you should immediately think word problem. That's what applications means in mathematics. So there's going to be some word problems in this section, and we'll get to them at the end. But with the machinery that we now have with inverse trig, we're able to do a lot more here. And I want to bring us back to the rules we talked at the very end of the last video about, which were these cancellation rules. We said, hey, as long as if you have a composition here where the inverse trig is on the outside and the regular trig is on the inside, as long as this little angle in here is within the range of the inverse function, then they'll just cancel out and you're left with whatever's in there. Um, and as reference, for sine inverse, the range was negative pi over 2 to pi over 2. That was the same thing as tangent, but tangent doesn't include the endpoints. And for cosine, the range is that upper part of the circle from 0 to pi. So as long as for sine inverse and tangent, your angle is between negative pi over 2 and pi over 2, and for cosine is between 0 and pi, the inverse trig and regular trig will cancel. And what's great about that is that for each of these, you'll notice, well, they all include quadrant 1. They all include quadrant 1, which is wonderful because that means if an angle is acute, so between 0 and 90, which is the same thing as 0 and pi over 2, make a note right there. As long as your angle is acute, we know that all of the trig functions, we can just take the inverse trig on the outside and we're able to cancel and get to the inside. This is really handy if we know an angle is acute. So small example here, we had sine of theta is equal to y, taking sine inverse on both sides. These cancel, you're just left with this theta right here. So this theta is this theta. And you have theta is equal to sine inverse of y. So this is really, really useful. We'll try it on a few problems. Not a big deal. Here, we're going to try to get theta by itself. We want to answer our answer in degrees. So make sure your calculator is in degree mode. We're assuming that theta is acute, and we're rounding our answer to the nearest tenth of a degree. To get rid of cosine, I'm going to take cosine inverse on both sides of the equation. So cosine inverse of cosine of theta is equal to cosine inverse of 0.75. So I'm on both sides taking cosine inverse. We know that the cosine inverse will cancel because theta is acute. We're left with theta is equal to cosine inverse of 0.75. And if you plug that into a calculator and round to the nearest tenth of a degree, you should get theta is equal to 41.4 degrees. If you're wondering how to get this cosine inverse on your calculator, so your calculator should be above the shift button, above the cosine button. On most calculators, it looks like this, and then there's like cosine inverse. And you have either a shift key or a second key that you push first, depending on your calculator. The easiest thing for you to do, go onto Google, type in how to do inverse trig on, and then type your calculator's model, and you'll find an answer right away. But most of the time it's like clicking shift or second, and then you click the trig button and it'll do the inverse trig. All right, cotan of theta is equal to 13 over 14. So here's the thing. There is no cotan inverse button on your calculator. unless you have the strangest calculator I've ever seen. Technically, this function exists because cotangent exists. Cotangent inverse, of course, exists. It just doesn't exist on any calculator. Typically, the buttons you have are sine, cosine, and tangent. So that's not a problem. All we have to do is think about cotan soulmate. Cotan soulmate is tangent, so tangent is just the flipsy-flu. So instead of 13 over 14, it's 14 over 13, just the flipsy-flu. And we do have a tan inverse button, so we're good. So tan inverse on both sides. So tan inverse of tan theta is equal to tan inverse of 14 over 13. Tan inverse and tan cancel. You're left with theta equal to tan inverse of 14 over 13. And if you plug that into your calculator, you should get 47.1 degrees. Ta-da! All right, last one. Cosecant of theta is equal to 3 over 17. Similar issue. No cosecant on the no cosecant inverse button on the calculator. So we'll look at soulmates again. Cosecant soulmate is sine. So sine of theta is the flipsy-flu, 17 over 3 as opposed to 3 over 17. And right now, in this moment, you should feel a little uncomfortable if you've built up some good trigonometric intuition here. When I asked this in my class, somebody said an answer I didn't expect at all, and it was a great way of looking at it. They said the hypotenuse is, or the hypotenuse is smaller than the opposite side, is what they said. And that's an amazing way of looking at it. So we know from SOHCAHTOA, so this is opposite over hypotenuse, and that would make the hypotenuse smaller than the opposite, and we know that's not possible. The hypotenuse has to be the longest side. So something weird has happened already. Another weird thing is that 17 over 3 is equal to 5.6 repeating, and we know that sine as a function only outputs numbers between -1 and 1 because it's the possible y values on the unit circle. So there's no way sine of theta is going to be equal to 5.6. It's just not going to happen, not unless you change this function and made it like 6 sine of theta. So let's say we didn't notice it and we went about our business, sine inverse on both sides. Sine inverse of sine theta is equal to sine inverse of 17 over 3. Cancel, cancel. You'll get theta is equal to sine inverse of 17 over 3. When you go to plug this into your calculator, you're going to get a math error. Depends on which calculator you have, what it says. On the Casio calculators, they'll call it a math error, which is different than a syntax error. Syntax error means it has no idea what you did. The calculator doesn't know what you did. Math error means I know what you're doing. It just doesn't mathematically exist. This is undefined. So it's telling us, hey, this is an undefined expression. I don't know what to give you. Undefined. That is. All right. So this process is really important because it allows us to do a lot with right triangles, which is what we'll talk about in our next video. Just pay attention to these weird cases with the side cast, and then pay attention to math errors and why they might be happening. If you're getting a math error, double check to make sure that what you've put in here is defined. All right. I'll see you in the next video. Bye.